let's talk about Kirchhoff's laws. And I know, you're probably thinking, great, more dusty formulas from a textbook. But what if I told you they hold a hidden power, a secret to seeing the very structure of electricity itself? Oh yeah, we've all been there. You're staring at a diagram that just looks like a tangled mess of wires, resistors, and power sources. It's overwhelming, and that feeling of not knowing where to even start is incredibly common. And that feeling, right there, brings us to what I call the complex circuit problem. It's this challenge every single physics student and electronics hobbyist runs into. That moment when a circuit diagram feels more like a piece of abstract art than a solvable puzzle. And the frustrations are always the same, aren't they? You feel like you have way too many equations to memorize. The circuits themselves start to feel just impossible to solve. And pretty soon, any intuitive sense of what's actually happening gets completely lost in the math. This is the real core of the problem. Kirchhoff's laws are so often taught as just two more equations to add to the pile. They become a chore, something you memorize for an exam, instead of what they truly are: fundamental principles that can bring beautiful order to all that chaos. So let's totally change that perspective right now. Let's reintroduce these laws, not as rules, but as the keys we need to unlock the hidden logic inside any circuit. First up is the voltage law, or KVL. Think of it this way. If you were to take a journey around any complete circle in a circuit, any energy you gain from a battery you must lose through components like resistors. By the time you get back to your starting point, it all has to balance out to zero. It's really just the law of conservation of energy applied to a loop. Next, we've got the current law, KCL. This one is all about junctions, any point where wires meet. And it simply says that electricity can't just vanish or be created out of thin air. Whatever flow of charge comes into a junction must be the same amount that flows out, even if it splits down a bunch of different paths. This is just the law of conservation of charge. So let's put them side by side. KVL is about voltage in a loop, and it's based on energy conservation. KCL is about current at a junction, and it's based on charge conservation. They're like this perfect little toolkit for the two different aspects of a circuit. Okay, now for the really exciting part. We're going to take these two principles and use them to transform that confusing mess of wires into something clear, elegant, and totally solvable.
The way we apply them is everything. This isn't magic. It's a method. By systematically looking for the loops and the junctions, we can reveal the underlying mathematical structure of any circuit.
Here's the method. First, you find your junctions and apply KCL. Then, you find your loops and apply KVL. And each time you do this, you get a simple linear equation. And trust me, a set of simple equations is infinitely easier to solve than a complex, chaotic diagram. And just like that, the hidden power is revealed. The complex circuit suddenly becomes a manageable system of equations. What once looked totally impossible now has a clear path to a solution. You're no longer guessing. You're systematically decoding the circuit's behavior. But this is about so much more than just finding the current in some resistor. This is about developing a whole new way to see and think, to start thinking like an engineer or a physicist. This right here is the ultimate takeaway. These laws are conceptual tools. They give you a framework for understanding how energy and charge flow and interact inside a system, which is the foundation of, all of electronics. So the next time you see a circuit, don't just see wires and resistors. See it as a complete system of flowing energy and charge. Use these laws to break down that big, scary problem into small, manageable pieces. This is the core skill that allows you to understand how everything from your phone to a power grid really works. And that leaves us with a final thought. We often treat so many principles in science and math as things to just memorize for a test. But what other amazing, powerful ways of thinking are hiding in plain sight, just waiting for us to see them not as rules, but as the incredible tools they truly are?